Okay, good morning, everyone. And our today's topic will be Docker. So it is Docker, and we will look at the architecture of Docker and how we use Docker and where Docker is used in DevOps. Okay, like I mentioned in our previous sessions, so now it has become the basic need for everyone in the industry to learn Docker. Everywhere, wherever you go, the applications are deployed through Docker. So yesterday during our topic, the main reason we the one of the significance of Docker that we learned is Docker is mainly used for effective utilization of the resources. So if we look at the users of Docker, first the first advantage is effective utilization of the resources. When I say effective utilization of the resources, how can we achieve effective utilization of the resources? So we quickly went through something called hardware virtualization and then containers. There are two changes in there were basically two evolutions in the industry with respect to the infra part. So that is something what we discussed. Initially, there used to be hardware like this. And the hardware like this, the hardware was hardware. Whenever I say hardware, it is nothing but CPU, memory, disk, network. So on top of this hardware, we used to install the operating system. And we used to install the operating system. The operating system used to come in two flavors. When I say two flavors, two stages. One is like internally, we used to have kernel space. So we used to call this space as kernel space. Means here to here, it is a kernel space, and here to here, it is a kernel space, and here to here, yeah, it is a user space. Here to here, it is a user space. So we can't directly interact with kernel. So we sitting here, we usually interact with the applications running in the user space. Means what we do, we do interact with the applications. Sorry, the applications running in the user space. So among such applications, one of the applications that we interact with the user space is shell. It is a shell. So in Linux, it is a shell. So that is what I did. And so I have connected to Linux operating system here. Today, if you look at the Linux operating system that I have connected, we can check that information using the command called cat/etc os release. So this command will give you what is the operating system that I have connected to. So in that, if you look at the pretty name, it says like Ubuntu and the version. So the version is 24043. LTS stands for long-term release something. The operating system that I have connected to is Ubuntu, means it is one of the flavors of Linux, and the version is 24.04, and remaining all the links like where we can get the packages. So this is the operating system, and like I told you, every operating system consists of two things. One is kernel, the other one is the user space utilities. To check the kernel, we use the command called uname-a. So this is the kernel that this operating system is using. If you look at the kernel, what is the kernel that operating system is using? So Linux is the type of the operating system. This is the host name, and this is the kernel. This is the kernel version. 16.6.14.0 is the main version, and 10.15 hyphen AWS is the subversion of the kernel. And this is the architecture, like what type of architecture this kernel was built built to, the architecture that kernel was built to. So when we say architecture, most of the people they get confused. So the architecture that they are referring to here is the CPU architecture. CPU architecture. So even when you when you go to market to buy um, what do you call laptops. So they give you different flavors, different types of laptops, right? Sometimes they say like the Intel based CPU costs high, and AMD based CPUs are there. And if you purchase AMD laptop, you get the same Intel like performance. However, the cost is less. And there are other flavors of CPU, like Mac comes with different CPU, like that. I mean, that we call it as CPU architecture. That we call it as a CPU architecture. Basically, we have two types of CPU architecture. One CPU architecture, we call it as x86 or x86-64. So x86 or x86 is 32-bit, x86 64. So this is one CPU architecture. Basically, this CPU architecture, you see it in Intel, AMD based processors, and there is one more CPU architecture that we call it as ARM CPU architecture, and that you see it in different processors we Mac comes with ARM, and there are different other processors, and you get to see ARM processors over there. So when we build kernel has to be built according to the architecture of the CPU. So that is the reason that you are seeing here. What do you see here? It is x86-64 architecture CPU. In the architecture that you see here is x86-64, and it is for GNU Linux. Means Linux is the kernel, and it has GNU libraries. Rest is SMP. I mean, these are architecture related information. So this is the kernel, and this is the operating system. Operating system is a combination of, like yesterday I told you, it is a combination of GNU utilities and the Linux kernel. GNU here is referring to GNU utilities. One of such GNU utilities is shell. One of such GNU utilities is shell. So when we interact with the operating system, basically we interact with user space processors. Shell is one of the user space processors. So the 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 terminal where I am executing these commands, right? ls or pwd or id or whatever commands that I am executing, these commands are executed as processors. These commands are executed as processors. Means these commands are executed as processors. So process means it is the execution sequence of a program. The execution sequence of a program in CPU. The execution sequence of a program in CPU is nothing but a process. Means what happens is, what is happening actually here is, we have CPU here, right? We have CPU here. I mean, let's say this is the CPU. CPU is a central processing unit which accepts the instructions, right? So when the instructions are loaded into CPU, will have registers and associated cache units, right? Initially, the instructions are loaded into the memory, and post uh, from the memory, the instructions are executed into the arithmetic and logic unit of CPU, and the execution looks like a process, and, that from operating system perspective, we call that as a process. We call that as a process. So these processes are nothing but the user space processes. Kernel space processes we can't see; those are abstracted to us. Whatever process we see, that is a user space process. So as a user, like we interact with user space applications, and one such applications that one we interact with is a shell. So when we look at this user space processes, right? When we look at this user space processes, they will have inverted tree like structure. So at the top there is a process called system D. System D will create a sub process, not only one sub process. The system D is going to create multiple sub processes, child process, child process, and this process will have one more child. This process will have one more child. So like this, these processes are organized in a tree structure, means tree structure. To see the structure of the process, that is the reason. Like sometimes I execute this command called PS tree. It shows the structure of the process. For example, tree system D is the main process, the first process, and it is creating multiple child processes here, like modem manager, ACPID, Amazon SSM agent, cron D, cron, dbus, etc. If you look at this, this is the process structure. This is the process structure. In this process structure, where am I? Where am I? If you look at, like I told you, as an end user, we don't interact directly with the kernel. Instead, we interact with like a shell, right? The shell currently that I'm interacting with is the bash shell. So you see, like I'm currently here. I'm currently here at this shell, and whatever commands that I'm executing, these commands are also executed as processes. These commands are also executed as processes. Okay, so that is the reason this process executed in the CPU, and it has printed this information to the terminal, and whatever information that we see here, all this information has been printed printed to the terminal, and the process has gone off. The process has gone off. So uh, this is how actually in Linux the processes work. So for understanding the theme, we can create a simple process. And so let's create a simple process. Okay. Um, vi test.c. Before that, let me run this command: apt update apt install gcc. These are package management commands. Slowly you will learn this while we go through Linux. Don't worry if you don't understand at this moment. Just focus on like what is a process, and like why we need to understand process. So let's create a simple C program, like the C program that we usually do. Like for example, test.c. So while we write C program, we write like this, right? A hash include stdio.h int main. So let's use simple printf statement, printf. So this is a simple program, right? This simple program, I mean, this is the source code of the program. Cat test C is to see the code of the program. So we can't execute this program as it is. Means that to execute that, we need to compile this program, because C is a compilation based language. So when we run test.c, so if you look at the files in the current directory, we use the command ls to see the files in the current working directory. There will be some hidden files. To look at those hidden files, we run the command ls-a. So you see, like, we have snap. Snap is a directory. Test.c is a file that we have created at this moment, and there are hidden files like dot double dot bash rc is a file. Dot chronicle is a directory. Dot profile is a file. Dot ssh is a directory. The file names in Linux, those start with dot or hidden files. Uh, if a file or directory name in Linux starts with dot, starts with dot, then that is hidden. Then that is hidden. That is the reason, like, when we run ls command will not show the file names which are hidden, which are starting with dot. So we have a file. The file that we have created is cat test.c. This is the file. So to use this file, I mean to okay, let me do one thing. So to execute this file, what we have to do is first we need to compile this. We have to compile this, right? So gcc -o. I mean, the simple compilation command is, if we run gcc test.c, so it gets compiled and it creates a file named a.out. So initially that a.out was not there. Now it is there. So let's remove that a.out. So I'm removing this, but I don't want a name uh, a.out to the file that has been compiled. So for that, I'm going to give a different name, gcc-o test.c. So now there will be a file named test gets created. So we have test here. So when I execute this test file, right, a test, so it gets executed, and whatever I have given in printf, that gets executed. Welcome to DevOps training. So that gets executed. So I mean, that gets printed to the screen. What it means is, when I run this test, the program, the instructions are loaded into the memory. The instructions are loaded into the memory, and those instructions gets executed. The execution, those instructions will be executed in the CPU. The execution sequence of these instructions, we call it as a process, and that process will learn will run for short time. The purpose of this process is to just print this information and go out. So that is the reason this process is going to run for a short duration. This process is going to run for a short duration. If you if you look at this file, whatever we have created, whatever the file that we have created. So we can check the characteristics of file using the command called file test. So if you see, the file type is ELF 64-bit LSB PI executable. This is the type of the file. So similarly, the ls command that I am executing, right? So this ls command is nothing but ls command is a file. Ls command is also a file. So where it is located is, if you run the command which ls, you see, like, where this ls command is located. It is located in /usr bin ls. To check the nature of this command, file usr bin ls, you see, it is like the test program that we have created. It is of type ELF 64-bit LSB PI executable, and the ls program is also ELF 64-bit LSB PI executable, and it has been built for the architecture x86-64, x86-64, and its version of the loader, CSV loader. It is a dynamically linked file, and the interpreter or loader is LD, and this is the build SHA hash, and you see, like, both are same. Similarly, date command is there. So if I run which date, so this is the date, and file /user bin date. So this is also an ELF executable file. So that's what yesterday I told you. So uh, like what is yesterday I explained you the difference between open source right? When we say open source, what is the meaning of open source? The source code is visible to us. The source code is visible to us, visible to us. So for example, I have written a C program and I know like what that C program does because the C program source code is visible to me. What is the C program source code? Cats test.c. So this is the C program source code. Similarly, the ls is also an executable program which is present in the user space of Linux operating system. So whenever ls gets executed, ls is going to print the files in the present working directory. This is a user space application, and this user space application is part of GNU GNU library. So GNU library and uh, and this is also uh, open source. Means if you go to GNU repository and if you search for ls code, ls application code, you will get it. So that's how these binaries are created in Linux. These binaries are created in Linux, and when we say when we refer to Linux operating system, we are referring to GNU utilities. Sometimes we call that as utilities. Sometimes we call them as binaries. Sometimes we call them as executables. I'll be alternatively using the terms towards these ls commands, executables, and binaries. And Linux is the kernel. Linux is the kernel. So the main purpose of explaining this is like to generate a process. To generate a process, what is needed is we have to execute a binary. We have to execute a binary. Only then a process gets generated. Means if I am running a binary or a command date, what will happen is a process gets generated. The process is going to run in the background, run in the background for some time. Sometime means for some time, and it is going to print that information to the screen, and it is going to go up. Similarly, if you look at the test application, if I run the test, it is printing this. So, but why I am not running test like the way ls is present? The ls is present here, right? So I can make that also. For example, I have test, right? GCC -o Kalesha test.c. So you see Kalesha test is there. So I'll move this Kalesha test to uh, /user usr bin. Now if I run the command Kalesha test, so automatically Kalesha test. So just if I run Kalesha test, it prints welcome to DevOps training on the screen. And how can this binary getting executed automatically? Because I have added this binary to this path, user bin path. So if you look at the environment variable echo $path, you see there are certain directories. If the file is present, the executable file is present, part of these directories, then no need to give the complete path of the uh, file, just giving relative path like Kalesha test, ls, date, pwd, it is enough. When we give pwd, the file is actually getting executed from this path, user bin. Since user bin is already part of bin, user bin is already part of the path, it directly gets executed. It directly gets executed. That is what actually it is happening. Uh, any questions so far? Let me know if you have any questions. Any questions?
No.
No.
Okay. Okay. Now let's do one thing. Let's create one more simple C program. Okay, to explain the same process, right? Vi but my sleep.c. So if you look at this program, what this program is doing is so I just copied it from the internet. Basically, if you look at this program, initially this program uh, will print this to the screen, sleeping for 30 seconds, and the process will be there in CPU for 30 seconds, and it is going to come out of that CPU after 30 seconds. So the reason for running this is, let me first compile this process. Okay, GCC -o my sleep.c. So I have compiled this, and my sleep is available here. Before that, let me do one more thing. Let me create a let me get the instance ID. Give me one more minute. I'm connecting to the same session, AWS SSM start session hyphen target start session hyphen target is I hyphen 091B08830 EF206F. Sudo hyphen I. So let me show you this through PS3. Export rank is equal to C. PS3. So you see, like I am connected to this operating system from two terminals, like two terminals. So like two bash processes. So you see, like the first one, I am here for the first session. I am here for the second session. So this is the first session and this is the second session. In my first session, I have created a simple C program, and let me execute that program. Let me execute that program. So if I execute that program, for example, my sleep, if I execute that program, the program is being executed. So now if I run the command ps3-p, so you see, like where is that executed? My sleep is executing under bash. So now if you look at the command ps3-p, so it is still executing, or it's still executing. Means it will be in CPU for how much time? It will be in CPU for 30 seconds. 30 seconds. And after that, it is going to come out. Now if I run the command ps3-p again here, ps3-p again here, do you see the sleep process? No, the reason is the sleep process, when I executed the sleep executable or binary executable or binary or command, it is doing whatever it is supposed to do. It is initially printing this message to the terminal. We call terminal as std out. Terminal is represented as std out /dev std out. Means this message is printed to /dev std out, and then the CPU is making the CPU is making this process to wait for 30 seconds, and post that it is printing this post that one more message is printed to the screen, and that I mean this is printed to the screen and the process came out. Means the instructions in the program are loaded into the memory, and those are being executed in the CPU. While the instructions get executed, the execution sequence of the instructions in the CPU, they look like a process, and those are the processes that we see in the user space. Those are the processes that we see in the user space. Those processes, they get generated through binaries or commands or executables. Or when we execute this, that is what actually happens. So in that means, let me run this my sleep again. So if I move this my sleep to move my sleep to USR bin. So if I just run my sleep here, again the command will execute, and if I look at the process here, like where is the process? Where is the process? PS3 -P. Where is the process? So if I look at the process, means the process is getting executed here. My sleep is a process. We have Aadhaar cards to identify ourselves, and Aadhaar numbers, PAN cards, PAN numbers, passport numbers. Like when you pass a degree, you will have roll number, etc. Every process will also have a unique identification number that we call it as a PID. 3436 is the PID of that process called my sleep. 3436 is the PID of the process called my sleep. And like where I am executing that process, like I told you, in a shell. Shell is also nothing but it is also a user space process. We execute commands within the shell. Shell is a environment. Shell creates environment to run our command. So the shell also runs as a process, and the PID of the shell is 1895, and the parent process of the bash shell is sudo, and its parent process is one more sudo, and its parent process is one more shell. Initially, I connected to this shell through SSM, and its process is SH shell. It is one more shell, and its parent is SSM session, and it is application program, and its process is one more SSM agent worker, and its parent is one more KW Amazon SSM agent, and its parent is PID with one, that is system D. PID with one, system D. Means this system D is the first user space process, and this system D is forking into multiple processes on the user space. So this is how the processes are organized. This is how the processes are organized. So when we run a Java application also runs as a process. The Java application also runs as a process in like a user space. Process in user space. So let me show you one example here. Let me show you one example. So any question so far here related to the process? All of you. If you have any questions, let me know.
So far, no.
Okay.
No, no.
So I mean, very simple, like means the binary or program composes of it is executable. It is executable. The next thing when we see an executable, right? So just now we have built one executable. What is the executable that we have built? Like mysleep.c. In this mysleep.c, we are using functions, right? So printf is a library function. Uh, Sleep is a function here. Again, printf is a library function. So there are functions. I mean, these are the functions. Uh, these functions are provided through libraries. So this is a library. The libraries give us functions. Okay, libraries give us functions. So means whenever we have a binary or a program usually consists of libraries, and through that libraries we are going to build binaries. So we are going to build binaries. So means let's say if I want to run any application, that application is a combination of libraries and binaries, libraries and binaries, uh, libraries and binaries. So so now coming to coming back to Docker, right? Why we need to understand all this is to understand Docker. Docker is a the use of Docker is effective utilization of the resources. We definitely do effective utilization of the resources. How we do this effective utilization of the resources? Because because the answer to this is container runs as a container runs as a process. Container runs as a user space process. User space process and looks like a VM and looks like a virtual machine. Virtual machine. So, I mean, like I'll explain you this statement. What is meant by this statement? Okay. So I connected to operating system here, right? I have connected to operating system. Like I told you, the operating system that I have connected to it /etc OS release. It is a Ubuntu based operating system that I have connected. So, like I connected to this operating system on a virtual machine, which is available in AWS. This is nothing but a virtual machine available in AWS. If it is a virtual machine available in AWS, like AWS will be. I'm calling this as a virtual machine. Means the hardware whatever I have, it is not a real hardware. It is a virtual hardware. So it is a virtual CPU, and we have memory, we have disk, and we have network. So on top of this hardware means we have this hardware, right? On top of this hardware, this is the hardware. So to manage this hardware, we have Ubuntu based operating system. So when we go with Ubuntu based operating system, initially to manage this hardware, we need a kernel. So this is a kernel. And what between this space, we call that as a kernel space. And we have a user space also. And so this is a user space. Let me, uh, wait. So this is a user space, means here to here. Mm, so this here to here, this is a user space, and this is a kernel space. This is a user space, and this is a kernel space. Okay, this is what is that we were discussing, like effective utilization of the resources, and I am justifying this statement, right? Container runs as a user space process and looks like a virtual machine. So this is something what I'm trying to justify. So currently, you see, like I connected to a virtual machine, So virtual machine has a CPU, memory. So to check CPU information, we use the command called /proc CPU info. So this is the command, and you see how many CPUs we have. Processor 0 and processor 1. So we have two CPUs here, two CPUs on this virtual machine, and the same we can see here with the top command, or yeah, proc CPU info is going to show us. And coming to check the memory, right? cat/proc mem info. So here we can see memory information, like what is the total, around 4 GB of memory I have on this. Then disk information, what is the hard disk? Like we can check df-h, and there is around how much GB? 6.8 GB size of root file system is present. Means around 7 GB of root file system is present here. That is disk. And coming to network, network, you can run the command IPA. So I have one ENX0 interface. This is one interface. LO stands for loopback interface. Loopback interface will have always this IP address 127.0.0.1, and this is the Ethernet interface IP address, and through which we are going to communicate to the external system. So you don't worry about it. Slowly we'll see what is a vCPU memory disk network. So whatever we are using, it is a virtual CPU, virtual memory, virtual disk, and virtual network. And on top of that, we have a kernel. Kernel, right? How to check the kernel? Uname -a. So it tells the kernel. This kernel is located in a directory called /boot. Whenever you see /boot directory content, there you see this file VM Linux 640 1015-AWS. This is the kernel file. If you go and delete that file, your operating system will not boot. If you join any organization and company, on the first day you can go to /boot and delete this, and the next day you can come out of the organization. So this is the kernel file. Okay, VM Linux 64. This is the kernel file. If this file is not available, means the kernel is not going to come up. The operating system will not boot. So and you see, like the kernel file is 6.14.0 10.15 AWS, and this is the same kernel version what we see here. The kernel version is 6.14.0 10.15 AWS. We are discussing one by one. We discussed about vCPU, memory, disk, network, and the kernel space, and the user space. In the user space, we see user space processes, and that, yeah, the easy way to check that is PS3-P. All these are the user space processes, and one of the user space processes that I am interacting here is the bash shell program, and the bash shell program is here. It's a bash shell. So this is the bash shell, and to this bash shell, I am connected in this terminal, and the PS3 command I executed. The PS3 command itself runs as a process and prints this information, and it goes off from the CPU. While this PS3 gets executed in the CPU, it looks like a process. Every process is identified with one PID. Okay. So till here we are clear, right? Till here we are clear. So now, if I ask you one question, what is the first process in your operating system here? What is the process with PID1 in your operating system? Can someone answer that?
System D.
System D. Okay. What is the process with process ID 1870? So you see this here, right? It is a batch process. Okay. So who is number one process? Means, so who is the first process always when a Linux system boots up? Who is the number one process always when a Linux system boots up? Number one user space process. It is always system D only. It is always system D. It is always system D. Okay. Is this clear?
Yes.
Means system D is the process. Means when you go to your Linux operating system, let's say you have two operating systems. Means operating system 1, operating system 2. If you go to operating system 1, what would be the first user space process? System D only. If you go to the second operating system, what would be the first process over there? It is also system D. Means every operating system will have one user space process with PID 1. Can I say like this? Means based on the understanding that we have so far, can I say if there is a separate operating system, every operating system will have a process with PID 1. Can we say like this? Yes, right? Yeah, we can say like this. So let me show you one magic here. I'm going to install Docker. To install Docker, the command is minstall docker, which is not M, it is a Ubuntu. apt install docker.io is going to install Docker. ctl status Docker. Docker is running. Let me show you one thing. Docker container run. Ubuntu. So if you see here, Docker PS, I am running 1, 2, 3, 4, 5, 6 containers. Means I have 6 containers. The Docker PS is the command to check the containers. I am running 6 containers. So let me connect to the first container, 3568 A45. This is the container ID. Just like we identify processes with PID, every container is identified with a unique ID, and we call that as a container ID. And every container is based on image. We'll discuss that later, and it will have a command to start a process. Just know, and the whole intention behind this explanation, like how a process gets created, is to explain you this concept called command. The through commands or through executables, when a command is run or when a executable is run, that is when a process gets generated. The process gets generated. So this is the command we are running to run this container. When this container was created, what is the status of the container? When we don't give any name to the container will get a random name like sleepy care, affectionate McLaren, etc., etc. So I have 6 containers here. So I'll go to one by one container each time. To get into the container, the command is docker container execc, or we can directly give execc, docker execc -it, and we can give container name here, sleepy care bash. So I am into the container. So you see like the prompt has changed here. The prompt has changed. This prompt will come from echo dollar. There is something called ps1. So this is the prompt. So you see host name I am using, host name and the present working directory. I'll explain this later. After art, we have \h, right? So this is the host name. Hence the host name of this container is this one. So that is fine. Like I'm telling you, like this container, the container. I mean, what is the statement that I'm justifying? So container runs as a user space process and looks like a virtual machine. So what if it is a new virtual machine? Every virtual machine has its own operating system, right? The operating system that it has is cat. Let me check. OS release. It has its own operating system. What is the operating system? Ubuntu 24.03. Ubuntu 24.03. So this is the operating system. It is Ubuntu 24.03 and uh, like every operating means it is a VM. It has its own operating system and it will have its own like how can we identify operating system? So by the characteristics of process, user space process. Just now we have seen, right? Every operating system will have two spaces, kernel spaces and user space. We can't see kernel space or we can't interact directly with the kernel space. Only space that we can interact with is user space. In user space, we have user space processes and usually the first user space process would be system D. Usually the first user space process would be system D. So how to check that using ps-ef command. So what is the first user space process here with PID1? It is sleep infinity. Sleep infinity is the first user space process. So by looking at this, since it has a separate user space process with PID1, can I call this as a virtual machine or operating system? Means container itself looks like a virtual machine and it will have its own operating system. It will have its own operating system. Let's create a container with a different operating system. I'm going to create a container with Docker container run -d. I'm going to create operating systems with CentOS 1 and uh, for now, I'm going to sleep for 3600 seconds. Docker container. What is the Docker run? Docker container. Docker container run -d. What is Docker container -d? And the same command we are running, right? Docker container run -d. CentOS sleep 3600. Manifest CentOS not found, unknown. Okay. CentOS latest CentOS CentOS is not there. Okay. Let's use Fedora. 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 Fedora is the operating system. So Docker PS. I have a container based Fedora. This is the container ID. Container name is using PTO Lemmy. Using and I'll connect to that container Docker exec-it musing PTOLEMY dash. I'm into the container now to check the OS. So it has its own OS, Fedora Linux. And if you look at the process, PS3 is not there. Just check with the PS-ef and PS is also not there. PS is also not there. Clear is also not there. Install proc PS. Just wait. So, PS-ef, you see the first process is a different process. Can I say this as a virtual machine? Means what is a container? What is a container? Container, you forget about this. It looks like a virtual machine. It looks like a virtual machine. Container looks like a virtual machine, but with respect to, I mean, it looks like a virtual machine, and the virtual machine will have operating system. Virtual machine will have its own OS, its own operating system. Uh, okay, it will have its own operating system, and it is a container. Container runs as a user space process. So this statement, container runs as a user space process, is with respect to the host OS. So we have two operating systems here. Basically, in this context, you see, we have two operating systems. What are those operating systems? So I'll go here, and initially we have hardware, right? We have hardware means CPU, memory, disk, network. On top of that, this is my hardware. This is my hardware, and on top of that, we are installing kernel, kernel, and we have base operating system. So if I go here, so we have a kernel, means this is a kernel space, and uh, and so this is my user space. So in user space, the first process in the user space is systemd, and it is it has spawned up into multiple processes, and bash is the process which I interact with. So like this, we have processes in user space. So the thing that I'm going to see is I'm going to call this operating system that is available here in this diagram as host operating system. We call this as the host operating system. The container is nothing but with respect to host operating system, it is just a user space process. It is just a user space process. The user space process by itself, since this user space process by itself, it thinks like I am my own operating system. The user space process by itself thinks like it itself thinks like uh, virtual machine, and it has own operating system. However, with respect to the host operating system, it is just a user space process. With respect to host operating system, it is just a user space process. It is just a user space process. How to check that? How to check that? We have been checking that using this command. What is the command? PS3 is the command that we have been familiar with. So let me get into the operating system again. So I'm getting into the operating system. Sudo -i. So PS3. So first check. Okay. First we have to do export lang is equal to C. Then PS3 hyphen P to show the PID. Where am I? If I ask, the first question that I am going to ask is which where am I executing this command? So I am executing this command here at this bash prompt, or bash prompt, and the command that I am executing is the PS3, and we have containers. We have containers with respect to the host operating system that I have created here. I have containers. You look at these containers. What are these containers? We have a container here, the sleep process, and this is one container. Means 4764 is one container. 4626 is one container. 4570 is one container. Sleep 4489 is one container. 4430 is one container. 4348 is one container. 4265 is one container. Who is the parent process of these container processes? Container process, container DSIM. Container DSIM is the parent process for each container process. Each container process. Each container process. So here the concept is. If you look at the concept, container is nothing but it is just a user space process with respect to the host operating system, and by itself it thinks like a virtual machine. It will thinking like it has its own operating system. having container having its own operating system, we already verified. There is a container with Ubuntu-based operating system. You can see, like when we ran this command, docker ps. I mean, if you look at cat OS release, cat slash etc OS release. So the operating system of this container is Fedora. However, the host operating system is Ubuntu. The host operating system is Ubuntu. The concept is very simple. We are projecting a normal user space process as a virtual machine, and the projection we call it as a container. The projected process is referred to as a container. So that is the reason, to understand containers, one must understand the process management in Linux. If you are familiar with process management in Linux, understanding containers would be very easy. So, like what what is the purpose of Docker here? Docker is Docker is Docker is projecting a normal user space process as a container. I mean, container is just a hallucination. Means container is means in realistic term there is no container. Container is hallucination. Okay. Any questions here? What is a container? Container is nothing but, with respect to host operating system, it is just a process. Okay. Any doubt here?
No.
Are you clear with the
Yes, sir.
process? Okay. Okay, that's it for today. And I'll share the recordings. I'll upload the recordings to Google Drive, and I'll share the recordings with you. Go through this and see. This understanding is very critical. Once you have this operating system basics and process basics, uh, containers, understanding containers, etc., would be very easy. Don't worry about that. So the reason for choosing this sort of explanation is, so if we start our understanding from the beginning, right? When you go when you start using containers, understanding the containers would be um, easier. And any concept, let it be container security, or let it be like container orchestration, Kubernetes, or let it be like any tool, like for you, understanding means you can easily understand the things. But if you go and read any book, or if you go and read any YouTube video, you can't find this information. Means they don't tell you. No one is going to tell you that container is just a user space process with respect to host operating system. They are going to tell like the container is application packaging mechanism, where application is packaged into uh, a container image, and we take the container image, and when we run the container image, container runs, container is magic, etc., etc. In fact, there is no magic. There is nothing. Container is just a user space process. Just like we created our C process, the similar process is also running inside the container, but container is assuming something. Container is assuming something. So whenever, if you want to understand containers, right? What I would suggest is uh, go and check. In analogy, if you want to understand containers, like go to YouTube and check for Ali comedy in Vinodam. So if you look at this, I mean, in Vinodam, uh, ఆలీకి ఈ సినిమాలో ఏం చెప్తాడంటే, ఆలీ పని మనిషి ఉంటాడు, వాళ్ళ ఇంట్లో డ్రైవర్ లెక్కన జాయిన్ అయితే ఆ, వాడు శ్రీకాంత్ ఏం చెప్తాడంటే, నువ్వు ఇంట్లో డ్రైవర్ కాదు, ఈ ఇంటికి ఓనరు, నువ్వు జమీందారు అని చెప్పి పంపించేస్తాడు. అంటే ఆలీ దాంట్లో ఎట్లుంటాడంటే ఒక రకమైన హాలూజినేషన్ లో ఉంటాడు. ఓ, నేనే ఈ ఇంటికి జమీందారు, నేనే ఇది కోటా నన్ను మోసం చేసినాడనే హాలోజినేషన్ లో ఉంటాడు. ఇదే కాన్సెప్ట్ ని కంటైనర్ లో వాడినారు. కంటైనర్ అంటే ఏంటంటే, కంటైనర్ యాక్చువల్లీ ఈజ్ జస్ట్ యూజర్ స్పేస్ ప్రాసెస్. కంటైనర్ ఒక యూజర్ స్పేస్ ప్రాసెస్ అంటే దాన్ని ఎట్లా ప్రొజెక్ట్ చేస్తున్నారంటే, ఒక ఇట్ సెల్ఫ్ ఈజ్ ఎ వర్చువల్ మిషన్. కంటైనర్ అంటే ఒక వర్చువల్ మిషన్, కంటైనర్ లోపల సపరేట్ ఆపరేటింగ్ సిస్టమ్ ఉంది, ఎట్సెట్రా ఎట్సెట్రా అని ఒక ఒక రకమైన హైప్ ఇచ్చినారు. దట్ ఈస్ ట్రూ. అంటే లైక్ దోస్ ఆర్ ద అదర్ సైడ్ ఆఫ్ ద కంటైనర్. బట్ విత్ రెస్పెక్ట్ టు మనం హోస్ట్ ఆపరేటింగ్ సిస్టమ్ నుండి చూసినాం అనుకో, సింపుల్ కంటైనర్ అంటే జస్ట్ ఒక ప్రాసెస్. మళ్ళీ ఆ ప్రాసెస్ ని మనం ఎట్లా వాడుతున్నాం అనే దాని గురించి వచ్చిందే లైక్ యూజెస్ ఆఫ్ కంటైనర్. సో ఇన్ సింపుల్ మీ అందుకే ఈ ఈ ఈ ఈ ఈ అప్రోచ్ ఇంపార్టెంట్. ఈ అప్రోచ్ ఇంపార్టెంట్. వెన్ యూ టేక్ హార్డ్ అప్రోచ్ టువర్డ్స్ లెర్నింగ్, ద థింగ్స్ ఆర్ గోయింగ్ టు బికమ్ వెరీ ఈజీ. మీన్స్ వెన్ యూ టేక్ సిస్టమాటిక్ ప్రాపర్ అప్రోచ్ టువర్డ్స్ లెర్నింగ్ అనేది చాలా ఇంపార్టెంట్. అండ్ ఈ అప్రోచ్ లేకుండా, లైక్ వెన్ యూ learn the things in a different way, the perspective changes, or somewhere you get stuck, or something you can't go deeper into the subject, etc. So today the ikkadiki topic inte endante, container is just a user space process in a host operating system. Okay, that's it for today. ఇంకో థియరీ సెషన్ ఇటువంటిదే ఉంటుంది. దాని తర్వాత we will completely jump into the use cases of containers, like how to use them, etc. మీకు ఏమన్నా డౌట్ ఉంటే చెప్పండి, అదర్వైజ్ దట్స్ ఇట్. Okay, okay then. Thank you for your time. Have a good day.
Thank you.
Thanks, Anna.